Let's kick off this Nano MOOC where we will explore the fascinating evolution of Ethernet as the most widely used layer 2 protocol. For a deeper understanding of reference models and protocols, we recommend revisiting the Nano MOOC Networking Basic Zero. Ethernet devices are all around us. In large data centers, they take the form of large boxes that connect numerous customers and devices. These devices often utilize optical interfaces capable of achieving speeds of up to 400 gigabits per second. But Ethernet devices aren't just limited to data centers. Look at your home. You will find Ethernet devices like your home internet router. These routers are small boxes that can directly connect up to 4 devices using network cables or copper interfaces. You may also notice that your home Ethernet device includes a wireless interface known as Wi-Fi, which enables connectivity for devices such as smartphones, laptops, TVs, and IoT devices like cleaning robots, security cameras, and much more. All these devices are interconnected through your home Ethernet device, with speeds reaching up to 1 gigabit per second. One important lesson to take away here is that Ethernet devices come in a wide range of speeds and sizes. Get ready for more enlightening lessons in the upcoming modules for networking basics.
Let's explore the intriguing history of Ethernet and take a trip back to 1971 in Hawaii. At that time, the University of Hawaii was trying to interconnect their campuses, which were spread across different islands. They came up with an innovative solution by inventing the first radio-based network using small commercially available transceivers. This network was relatively slow compared to today's standard, transmitting only a few hundred bits per second. The transmission process in the early network was remarkably simple. If you had data to send, you simply transmitted it. If, during your transmission, you received something else, indicating concurrent transmission from another station, you would stop and try again later. This straightforward principle formed the foundation of the Aloha network at the University of Hawaii, an uncomplicated yet effective way to transmit data. Consider this analogy. It's similar to a group conversation where people join in when there is a moment of silence. If 2 or more individuals start talking at the same time, they politely pause and wait for a few seconds. In informal conversations, there is no moderator. It's all about accessing the conversation randomly. In 1973, at the Palo Alto Research Center of Xerox, a plethora of inventions emerged, including the mouse you are currently using. It was there that Robert Metcalfe drew inspiration from the radio transmission of the Aloha network and adapted the concept for use with coaxial cable, similar to those used for TV antennas. Coaxial cables proved to be excellent, affordable, and reliable transmitters, enabling the increase of speeds up to megabits per second using affordable electronics. The entire setup was standardized in the early 1980s as Ethernet 2 and IEEE 802.3, which still forms the basis of our current Ethernet standards used in homes and data centers. The initial speeds were 10 megabits per second, a remarkable improvement compared to the few hundred bits of the Aloha network, with a maximum distance of 500 meters. The coaxial cables used was approximately 1 centimeter thick and colored yellow. Transceivers, known as vampire taps, punctured the cable, allowing Ethernet devices, for example computers, to connect along the coaxial cable. The configuration was standardized as 10^5, signifying 10 megabits per second baseband transmission and a maximum distance of 500 meters. The next Ethernet standard, known as 10^2, maintained the speed of 10 megabits per second, but introduced a simpler cable with a maximum length of 200 meters. Plugs replaced the vampire taps in this evolution, and it became widely adopted in the 1980s and 1990s, earning the nickname Cheaper Net. The subsequent version, called 10^T, still maintained a speed of 10 megabits per second, but replaced the coaxial cable with twisted fiber pair cables. First with 4 wires and later with 8 wires. A significant difference from previous standards was the introduction of a central device, a switch box, which connected each computer to the central device using twisted pair cables. This new topology improved the reliability of the network significantly.
Throughout our learning journey, we have discovered that Ethernet, as the most widely adopted layer 2 protocol in networking, is not a recent invention. Instead, it has evolved over several decades to keep pace with technological advancements. Ethernet has continually adapted itself to support increased speeds, following the path of evolving technology. It initially utilized radio modems before transitioning to various types of coaxial cables. From there, it made a shift to copper pair cables and eventually embraced fiber optics. Through these advancements, Ethernet has maintained its fundamental access mechanism, as previously explained, an analogy to a group of people engaged in an informal conversation. However, it is important to note that Ethernet has not existed in isolation. In our upcoming content, we will explore its competitors and delve into their respective roles. Join us in the next module for more exciting insights. Until then, take care and see you soon.